all are good and doing well for the preparation of your upcoming CIEs. Guys, here I'm going to discuss a few important concepts of complex number with the request of you students and complex number equations and loci. Okay, the first question here, I took this question from the past year papers, and it's very much important to discuss at this moment the past year papers. On a sketch on an Argand diagram, shade the region whose points represent complex number z satisfying the inequalities. Okay, here we have inequality number one like this. We have this one and this one. The first inequality, that z minus 3 minus I modulus is less than or equal to 3, can be written as z minus 3 plus iota 1 iota modulus less than or equal to 3, which shows a circle with center, like center is z minus a plus bi. So center for this center will be 3 comma 1, and radius is 3 here, this one, right? This is the radius and this represents the center. I hope it is very much clear. Now we have to plot this first. Okay, this is an Argand diagram. And here we have real axis on along x-axis, real of z, and here vertically we have imaginary axis of z for the complex number. And try to keep the equal spacing on both axes. Once you are plotting here 1, here equal spacing 2, 3, you can use the scale to measure the equal spacing on either axis. So how much you will good in the equal spacing, that will justify your better result. -2, -3, and so on. Here it will be same on y-axis. Here 1, here's 2, here 3, and so on. Same here is -1, -2, -3, and so on. Okay, let's plot the circle with center 3 1. 3 1 will be here. 3 1 is the center here. This, and this is the center of circle. And as it is 3, having 3 radius 3, so along the center we can place the one circumference point will be 3 unit here, and other will be 5 and 6 here. So I'm going to this, and 3 unit up is 3 and 4 will be here. So I can place this. Or you can plot this by taking do open the compass of with a scale of 3 radius 3 centimeter, and you can plot a circle then. And from here 1, it will be 1 down and 3 here, -2 and 3 will be here. So here in this way you will plot the circle like this. And as I told you, that your equal spacing will matter here, so let me make it more accurate. This seems to be better, much better. Okay, this we have done, and as it is equality with the, here with the inequality we have equality as well, so circumference boundary will be in solid. Okay, now go with the second option of inequality. You are given here z modulus is bigger than or equal to z minus 4i. So this is the perpendicular bisector form with we can say, which shows perpendicular bisector of form, yani like z minus a, z minus b between points a and b, points a and b. So first to check what is a and what is b here. So I can write this z minus into 0 plus 0i modulus greater than or equal to z minus 0 plus 4i. So it means here, by comparing this with the rule here, I can say the one point is 0 0 and the other point b is 0 and 4. So I need to make this perpendicular bisector of this one on it. So 0 0 is here, yeah, and 0 4 is here. So half of this will be in mid of AB, perpendicular bisector 0 plus 0 by 2 comma 0 plus 4 by 2. So I will find it at 0 and 2. So 0 2 is here. Let me draw with the black one to make the difference. So here perpendicular bisector on it, it is the line AB. Perpendicular bisector will be parallel to here. It's equal to, bigger than or equal to. So I will draw this line. This is a perpendicular bisector M of AB on the circle, and as the condition says, the first one inequality says and z minus 3 minus iota is less than or equal to 3. So all the shading inside the circle less than 3, and this says z z modulus of z is bigger than z minus this one. So it means it should be the bigger than this perpendicular bisector. So you can have this shading of this one, that is bigger than this, yeah, and less than 3. All area above this line bisector and less than the circle. This is the answer. I hope you got it. This is the shading part, and that represent this. Okay, now I hope it is clear, and this is the loci what I have done with the given statement on an argand diagram. Let's proceed to the next question. Okay, here it says on a sketch of an argand diagram, shade the region whose points represent complex number z, this, and real of z is this, and argument mean angle is this. Okay, so first of all we have inequality first, that z modulus is less than or equal to 3. That shows a circle z with center 0 plus 0i modulus less than or equal to 3. So it shows a center, a circle with center, a circle with center 0 0 and radius 3. That shows the first inequality, and the second is real of z is greater than or equal to minus 2. This shows a straight line parallel to imaginary axis, imaginary of z, at point -2 on real axis. Right. Third inequality is given to us is argument that angle pi by 4 less than equal to angle of z. Argument z is less than equal to pi. It means your angle is lying between 0 and pi. Generally, you know the angle here. Note the angle. You know, argument of angle z. Argument here. Argument angle z must be between minus pi till pi, right? And here it is given arc angle. So we have to plot this on an Argand diagram. So I will sketch the Argand diagram first here, and okay, this is real of z, imaginary of z, and same goes on either axis, positive and negative. So suppose we have here 1, 2, 3, 4, 5. Okay, here goes with the same -1, -2, -3, -4. Then here it will be, here is 1, 2, 3, 4, 5. Same goes down, -1, -2, -3, and so on. I recommend you to use scale to keep the equal spacing. That helps you to plot it in a perfect way. Okay, the first one is about origin. So circle is from starting from here, and radius is 3 unit. Here it will become here, -3 here, 3 up and 3 down. So you will plot the circle like this. This is a circle. Okay, with radius of 3. Now second one, we have to plot the line at negative of real of z. It will be parallel to imaginary axis. Here it will be, line will be solid because it shows that real of z is greater than or equal to 2, -2. Okay, here this is real of z equal to -2, and this is what this represent, modulo of z is less than or equal to 3. And third one, now we have to go with the argument. So let me write it here. Modulo of z is less than or equal to 3. Angle. For the angle, we need to do some calculations if required. As you know, your angle is bigger than minus pi by 4, that is 45 degree, until 180 degree. So okay, first of all we will plot here. Let me take the black one. Okay, pi by 4, as this angle total here is this is pi by 2, pi by 4 will be here. I can write this angle as pi by 4, and we know it's bigger than pi by 4 but less than or equal to 180, and in total is this here it is the first two quadrant, that will be let me write here, it will be here, this is pi, right? Here this comes to pi, but we know it should be less than and less than pi, equal to pi, but bigger than or equal to pi by 4. So, and the shading part must satisfy these inequalities. So I will take this. So first option, real of z is bigger than or equal to -2. All the area comes here this side. I need to shade this one. Okay, -2 as well. All area, but the area which is satisfying the three inequalities, that the second one, the radius should be less than 3. So it must be here, I think. Yes, inside the circle. And the argument of z is bigger than pi by 4 but less than this. So it means that only for the circle is less than 3, it should be inside the circle. And this shading part will justify the inequality. The angle is bigger than pi by 4 but less than or equal to pi. So this will be the true part or true region which we need to shade. I hope it is clear, right? Here goes another question. On a sketch of an Argand diagram, shade the region whose points represent the complex number z satisfying the inequality is this one. So first inequality says that it is a circle with certain radius 1 and center 1 and -1 and 1, and then argument z minus 1 is 3 by 4 pi. Z minus 1 is 3 by 4 pi. Let's see how to plot this. Okay, z plus 1 minus I modulus is less than equal to 1. That means z minus 1 plus I modulus is less than equal to 1. That's represent, which represent, that means a circle with center 1 1, sorry, minus 1 1, minus 1 1, and radius should be 1. Okay, the next one is what is given, argument angle of z minus 1 less than equal to 3 pi by 4. Okay, we have to plot this one should be the, you know, the y-intercept on line on the Argand diagram. Let's see how. Here, this is Argand diagram, real of z, imaginary of z, and first plot the circle with center. This is 0, here says -1, -2, -3, -4. Okay, here 1, here 2, here 3, 4, then same goes 1, 2, 3, and so on. -1, -2, -3, and so on. Okay, now plot this first one. Circle point center is -1 1, -1 1, circle center is here. Okay, radius is 1, so 1 point here, 1 point here, 1 point up, 1 point down. So this will be the circle. Okay, we'll do this. Next one is the, you know, first we plot this y-intercept z minus 1, argument z minus 1 is, it means the line, it should intersect from the y-intercept, that is here 1, and it's 3 pi by 4. Any pi by 2 is here, 3 pi by 4 should be, you know, here starting from 1 1, x is 1. Yeah, the line will be passing through this. So the angle is this one from the positive axis, that is 3 pi by 4, because here argument z minus 1, it means intercept is 1. At 1 1 we will have 3 pi by 4, but we need to shade that is less than 3 pi by 4. 3 by 4 is here, so I need to shade this one only, because this shading area, let me get the other color with blue. Yes, this shaded area I need to shade it, that is less than 3 pi by 4 and less than 2 as well, or less than 1 as well, the circle. So this is the shading region which we will require to satisfy this loci. I hope it is clear. Okay guys, here goes another question of different case, that here now you are dealing two inequalities. This first says z modulus is bigger than or equal to 2, says that this is a circle with the with center 0 plus 0 I. It means circle with center is 0 0 and radius is 2, bigger than or equal to 2. Okay, also you are given second inequality, minus 1 plus iota modulus less than or equal to 1. This also represents the circle with center 1 minus 1, modulus is and radius is less than or equal to 1. Center is 1 and minus 1 and radius is 1. Okay, let's draw it and then we will shade it. On Argand diagram we have this real of z, imaginary of z 0. Okay, the first one, center 0 0. Say here we have 1, we have 2, 1 2, minus 1 minus 2, and so same here, it's minus 1 minus 2 and so on. Okay, first draw this circle. Center is 0, radius 2. One point is here, one point is here, one point goes here, one point goes here. Circle will be this. Okay, we drew this circle of radius 2. Now the second on the same, let me take the other color. Yes, center is at 1 and minus 1. 1 and minus 1 is here. Center is 1 and radius is 1. So it means one point will be here, one point will be here, one point will be here, and one point will be here. So the circle will be this. This is the circle number 2 with radius 1. Now we need to shade the region that first says that radius should be bigger than or equal to 2. Right? It means it should be out of this region 2. And second one says less than or equal to 1. So this seems to be the best option to satisfy the first one. Radius goes out of the circle 2, and the second one says should be less than 1. So this is a true shading area. This is a loci for the two inequalities. I hope it is clear. Yes, and guys, I suggest you to work on the basic properties of sketching the circle. The three cases we have in journal here. Either we need to sketch the circle with radius, or we have a perpendicular bisector line, or the third case is about the argument of the angle and angle range. So these three cases you need to work on. More practice of these topics from the topicals that you have with you, and keep watching more videos on the loci. I will send after this more practice questions to work on. Good luck.